Welcome to the Unit 3 Lesson 4 video. Go ahead, pause the video, work through these warm-up problems. You're just adding or subtracting like it says. When you're done, you think you got them all right, unpause and then see how you did. So I'm going to make this video again. My recording part kind of screwed up earlier, and so I'm having to re-record this. So if you think that I went through something quicker than I probably should have, it's totally possible. It's the second or third time I've actually kind of looked through this thing today. So usually I go a little bit faster. Just ask your teacher if you've got questions and you think I went too fast. So number 1 is -2 for an answer. +2 for number 3, or for number 2. For number 3, I've got -1. Minus a negative is like adding a positive, so I've got 17 for number 4. -7 for 5. -1 for 6. 2 for 7. 8 for 8, 2 for 9, and finally 0 for 10. So today we're going to be substituting values in for variables in inequalities to make sure that it's still true. So I'm going to start off. There's going to be a bunch of scrolling in this video. I'm going to apologize right now. So we're starting off with 4 is less than 17. That's how we read that. 4 is less than 17. That 100% is true. 4 is smaller than 17. Now we're going to have a general statement with variables of x is less than y. I don't know what x and y are individually, but I know that x is smaller or that y is bigger. And what we're going to be seeing in a little bit is we want to see if x plus b is less than y plus b, if that's true or not, where b is some number. So to show it's true, we're going to pick values for x and y. We're going to pick so that we have x is less than y. So they said x equals 0, y equals 3. 0 less than 3 is a true statement, so we're starting there. Now we're going to fill out this table. What we're going to do is we're going to pick a value for b. It doesn't really matter. We're just going to pick a whole bunch of different values and see if they're true. So we're going to plug in 4. If I plug in 4, I get 4 is less than 7. Is that statement true? Yes. Yes, it is. So what they're going to do is they're going to put a check mark next to that table and say, yep, this works. And we're going to do the same thing, except for instead of +4, we're going to put in a -4. So plus and -4 is just like subtracting. -4 is less than -1. Is that true? The answer is yes. Remember, on a number line, like these numbers are easy, but we have the kind of the reflection of that. The further the number is to the left, the smaller it is. So even though 4 is bigger than 1, -4 is less than -1. Think of it as more negative if you want to. So they're just going to fill in this table. I'm going to scroll until we get to the end of that table. There's a bunch of little clicks that I would have had to gone through if this was a PowerPoint. So they checked 4 values. They checked 4, -4, -2, and -1. And all of those turned out to be true. So what we can say is that no matter what number we add to this statement on both sides, if this is true, then that is true. All right, think of that seesaw example that we talked about when it was an equal sign. If I had something that was like 50 pounds here, with 50 pounds here, it'd be perfectly balanced. With an inequality, if I have that inequality, for example, it means this thing on the right side is bigger. So I'll say it's 51 pounds. So this side would be coming down and this side would be going up on that seesaw. If you add 5 more pounds here and 5 more pounds here, it's not really going to change the orientation of that seesaw. This right side is still going to be down. This left side is still going to be up. The same amount that it had been. Okay. This one's just a little bit lower because this number is a little bit bigger. So on that number line, we're going to plot those points we talked about and see if it's true or not, which we already know it's true. So we're starting off with 4 less than 7. Is that true? Yes, 4 is further to the left. If I plug in the points, -4 shows up right there. -1 shows up right there. Negative 4 is further to the left, so yes, negative 4 is less than negative 1. And then this next one, there is a small error because they have positive 1, but they put it at negative 1. So if they were trying to put it at positive 1, this would actually go there. Negative 1 would go where it is. So a small error, but regardless, the statement would still be true. Negative 2 is smaller than both of those. And then the last one, negative 1 is less than 2. Negative 1 is further to the left, so yes, that is also true. So, like I said, anytime you have if x is less than y, if you add the same amount to both sides, you still get a true statement. So x plus b is less than y plus b. If b and b, if one of them was different, this is not necessarily true. So that b value has to be the same. So it's a problem, but it looks a little bit strange. So I'm going to kind of walk through what to expect for this. So we've learned the following general statement. So if x is less than y, then x plus b is less than y plus b. Now we want to see if that's true for instead of plus b, if we are subtracting b. So they've already filled out a whole bunch for you, and then you're going to be filling things out as well. So this negative 3 comes from right here. All right, so everything in the box is something that's written over here. If I'm looking at the statement x minus b, y minus b, this next box is going to be filled in with positive 3 because I'm subtracting 3. Which means the next one will be minus 1, then positive 1, and 0, negative 2, and 2. All right, so I'm going to fill those in for you, and then I want you to just go through and say if this is true. Is it yes, it's true? No, it's not true. And so you're going to be looking at these pieces right here. All right, so pause the video, tell me if those are true, unpause the video, and see how you did. So negative 7 is less than negative 1. That's true. Negative 3 is less than 3 is true. Negative 5 is less than 1 is true. Negative 4 less than 2 is true. Negative 2 is less than 4 is still true. And negative 6 is less than 0 is true. So yes, x minus b is less than y minus b is going to be true anytime x is less than y. Same thing with that seesaw. If I take that extra weight off both sides, it doesn't change how which side's heavier or not. So next we're going to have a few problems where we're using unit rates. So there are 8 problems here if I remember correctly. I'm going to do 2 of them with you. I'm going to do number 1 and number 5. So it says solve the unit rate problems. Remember, unit rate, unit is just one thing. So if 6 cartons of milk cost $3.60, how much is 1 carton? Bumped a button, sorry about that. Well, let's see how much I have to scroll now. The answer is quite a bit. All right, so I'm comparing cartons of milk, I should say number of cartons of milk, to the total cost. So if I get 6 cartons of milk, that's $3.60. I don't have to use the symbol, I'm just looking at the numbers. How much is 1 carton? I set up a proportion like this, and then I've got to use my horizontal or my vertical method. Either one works. I'm going to divide horizontally by 6. If I divide this out, I have that decimal there, I get 60 cents. Remember, the dollar sign goes out in front. So that's what you're going to be doing for that first activity. For the second activity, it says examine the special pricing situations and determine the better deal. Better deal is just which thing is cheaper by unit. So like I do this when I go grocery shopping. If I'm looking at similar products, just different brands, I look at the cost per ounce, the cost per thing, the cost per something. That 1 per something is how I determine the better deal. So for number 5, Hal's Grocery sells 12 apples for $2.40. So I'm comparing number of apples to the cost. All right, so he gets sells 12 apples for $2.40. I want to know that thing's unit rate. So for one apple, what is the cost? I know right here it says one apple costs 25 cents, but that's what I'm comparing it to. So like 12 apples for $2.40 is one deal, and then 25 cents for an apple is a different deal. I need to determine which one is better. So I'm not going to put one apple 25 cents, and I don't have a variable. It doesn't really help me at all. So I'm going to choose to divide horizontally by 12. Okay, that tells me that X is going to equal 20 cents. Okay, if I were to divide 240 by 2, I would get, or 240 by 12, I'd get 2, but I got to move the decimal. So that's where I get my 20 cents from. So I didn't answer the questions yet. It says which is a better deal. The 12 apples for $2.40 is a better deal. And I gotta think to myself, why? All right. The reason why it's a better deal is because if I think of the cost of one of these 12 apples is 20 cents, that's 5 cents cheaper than if I just get one apple by itself. All right. So this is assuming I'm going to be eating all 12 apples. I'm not wasting money, but all things considered equal, 20 cents is going to be a better deal than 25 cents. So go ahead and do those last 6 problems, unpause the video, and then see how you did. So number 2, we're talking about how many miles she drives per hour. So 420 miles for 7 hours, I'll say hours I guess, is I don't know how many miles in 1 hour. All right, I'm going to divide by 7 to get that X is equal to 60. So she drives 60 miles. I should have a label, and I should try not to have my work show up in that sentence blank. But Anna drives 60 miles in 1 hour. Number 3 is similar to number 5 in the sense that it's talking about apples. So I'm going to say number of apples to cost. 5 apples is $2, not $20. That'd be ridiculous if apples were $20 for 5 of them. How much is 1 apple? I'm going to do horizontal again, divide by 5. If I divide by 5, I get 0.40, so the cost of 1 apple is 40 cents. Number 4, number of tickets to the number of rides. So 25 tickets gives you 5 rides. I don't know how many tickets give me 1 ride. I'm going to change it up and go vertical this time. Multiply by 5 to get X equals 5. So the number of tickets for 1 ride is 5. I'll even throw the word tickets in there. 5 tickets. Number 6, Nature Snacks sells fruit snacks by the pouch for 50 cents or in a 12-pack for $5, which is the better price. So I'm talking about number of pouches or packs. Either one works. My unit rate for this 12 one, I have a 12-pack for $5. I don't know what it costs for one of those. I'm going to use my horizontal method. Now if I'm doing this, 5 divided by 12 is a little bit challenging, so I'm going to put on a couple decimals there. 12 goes into 50 4 times. It goes into 20 1 time. And it goes into 8 6 times. And it would keep going. But I don't really care about that. My unit price is money. Money always only goes to 2 decimal places. So I went to 3 to determine if this thing would round up or down. So my X is going to be 42 cents because I would round up to the nearest cent. So which is a better deal? Buy the pouch for 50 cents or get a whole bunch for 42 cents per pouch. So the 12-pack is a better deal. Number 3, Natalie's school is selling raffle tickets as a fundraiser. I think this one's going to be really, really easy, and doing math is actually going to make it a little bit more tricky, I guess. So number of tickets over its cost. If I have $10 for 10 tickets, and I don't know what the unit rate is, okay, that's going to be a really easy one to find. That would tell me x is equal to 1. If I use my horizontal method, my vertical method, or if I just do 10 divided by 10 is 1. So I need to find the unit rate for the other one. I'm going to use the other color. So 4 tickets for $5 is equal to 1 ticket for, I don't know how many dollars, but I need to find a different variable. Now at this point, I'm going to divide by 4 horizontally to get that y is equal to 1.25. Now I kind of ran out of room here. They're not spaced out very well, but this number is higher than that number, so that means this one is the better deal. So I'm going to write that in green over here. So 10 tickets for $10 is the better deal. The reason I said this one might be easier than just having to do math is because I feel like we should all be able to look at it and go, all right, 10 tickets for $10, it's $1 a ticket. 4 tickets for $5 is more than $1 per ticket. $1 per ticket's going to be cheaper. And then number 8, suppose sugarless gum is sold in a 10-pack, or pack of 10 sticks for 80 cents. Another one is 20 sticks for $1, which is the better deal. So I'm going to say number of sticks to the cost. So the first one, I have 10 sticks for 80 cents. So my unit rate is 1 to x, like this. I'm going to divide by 10. When I'm dividing by 10, it makes my life easy. I just have to move that decimal 1 spot to the left. So similar to like number 7, I'm going to have to find a second unit rate. So I'm going to do 20 sticks for $1 is equal to 1 over, and then I use a different variable, y, this time because I've already used x in this problem. All right, you can divide by 20 vertically or horizontally. You literally are going to have to do divide by 20 no matter which one you use. So 1 divided by 20 is going to be 0. Well, I'm not sure off the top of my head, so I'm just going to come off to the side and write it out. So 0.05. 5 times 20 is 100. So 0.05. That is smaller. So the pack of 20 sticks is a better deal. All right, so that's mathematically what we're doing. We're finding unit rate. If you're doing some of this as you go shopping, some of these might be a little bit easier. For example, if I'm doing number 8, like in the grocery store aisle, 10 sticks for 80 cents, 20 sticks for $1, I get twice as much for less than twice the price. 20 sticks is going to be the better deal. It's kind of a way to check our answer. All right, so make sure you're taking care of your homework, and I hope everybody has a great day.